Hello everyone, welcome to the second part of this course. In this part, I am going to discuss about the AC circuits. In first part, we have already discussed about the DC circuits, means those kind of circuit which is excited by the constant DC supply. And in this part, we are going to explore the circuit excited by the time varying AC sources. So again, I will start with the definition of AC circuits and what is the response of AC source on the RLC network. So let us start the course that is based on AC circuits. So we are going to do analysis of circuits in which the source voltage or current is time vary. So we are particularly interested in sinusoidally time varying excitation or simply excitation by the sinusoid. So let us try to understand what is meaning of sinusoid. So I'm going to take the different color. So definition of sinusoid. So a sinusoid is a signal that has the form of the sine or cosine function. So basically our source, so I will draw one circuit. So let us take again the blue color. So this is our source, and suppose that some connection, so I have taken resistor, some kind of inductor for simplicity. So this is our circuit. So here this source, suppose for time being current source Vs, so that is looks like some kind of Vm sin omega t, or something like Vm cos omega t. And this is our resistance and this is our inductance, and I have some current I. So sine function and cosine function is collectively known as the sinusoid, and one can now define the AC circuit. So AC circuit, in order to define AC circuit, we are going to take help of the previous definition. So basically, definition of AC circuits. So circuits driven by sinusoidal current or voltage sources are called AC circuits. So this is the definition, and from this definition you can able to understand that whatever circuit I have drawn here, that is one of the AC circuit, because here I have taken excitation source as a sinusoidal source, that is of time varying, let us try to discuss something more about the sinusoids. So I am going to discuss more about the sinusoids. So my next discussion is based on the sinusoids. We began with a basic discussion of sinusoid. Consider a sinusoidally varying voltage. I have considered the voltage source, which is represented by Vt equal to Vm sin omega t, where Vm, that is the amplitude of the sinusoid, omega the angular frequency in radian per second, or omega t, the argument of the sinusoid. Now I am going to plot the Vm sin omega t as a function of argument omega t. So I have taken vertical axis as a Vt and horizontal axis as a omega t, that is the argument of sinusoid, and you all are already well aware that the response, so let us change the color, so that is represented like this, something like this. So this is Vm and lower part of this is minus Vm, this is pi and this is 2 pi. Similarly, this is something like 3 pi. One can also redraw same function like this. Here vertical axis is again Vt, but horizontal axis is now time. So again I will choose different color. So again this is the nature of the function, so nature remains the same, and here this point is something t by 2, this is t, this is 3t by 2, and again here peak point is Vm and this particular thing is minus Vm. It is evident that the sinusoidal repeats itself every t second. You can see that kind of repetition, and during school time also we have learned about this. Thus t is called the period of the sinusoid. So here basically t is the period of the sinusoid, and from plot one can also write one relation, that is omega t equal to 2 pi, which further implies t is nothing but 2 pi by omega. We also know the frequency is the inverse of the time period, so I can write f equal to 1 by t. Therefore one can express this particular thing like this also, means f equal to omega by 2 pi. You all are aware about the periodic function. So let us see the formal definition of the periodic function. So definition of periodic function is like this. Periodic function. So a periodic function is one that satisfies ft equal to ft plus nt, where n is some integer. So this relation is true for all t or for all integer n. If some function will satisfy this particular equality, then we can tell that that function is periodic. And it is pretty easy to check that whatever function I have selected, that will satisfy this property. So let us see that vt plus t equal to vm sine omega t plus t. I am assuming that period of this function is t, and we know that vm sine omega. So from the previous relation I can substitute t equal to 2 pi by omega. So that is 2 pi by omega. Further I can write like this: vm sine omega t plus 2 pi, which is equal to vm sine omega t, and basically that is exactly equal to vt. Therefore I can write vt plus t equal to vt. So basically we have just revised about the one class of sinusoidal function that is represented by sine wave, and after that we have seen that that is periodic. So basically that is changing their sign. Sometimes they will take plus vm, sometimes they are take minus vm. So basically that represent the one class of AC voltage source.